Hello, grade 10s. So in our last lesson, we talked about ionic bonds and what makes an ionic compound. This is when you have a metal that has one or two outer shell electrons, and it wants to get rid of those outer shell electrons so that it can achieve a full outer shell using the least amount of energy required. Easiest way for it to do that is to give away those two or one electrons. Where does it give them? Well, it gives them to a nonmetal. When it's brought into close proximity with an element or an atom that has 6 or 7 outer shell electrons, well, that atom's looking to do the same thing. All elements, all atoms are looking to gain that full outer shell. So there's a transfer of electrons there. So one of the last things we talked about in sorry, I'm just trying to get rid of this right now. One of the last things that we talked about in that lesson about ionic bonds was that we can either transfer electrons, we can either give them away, we can be an atom that is a metal and we can give electrons away, or we can be a nonmetal and we can receive electrons. The third way to form a compound is to share electrons, and that's what we're going to talk about today. When atoms share electrons in their valence shell, rather than having a transfer, we call this a covalent bond. So a molecular compound is made up of one or two covalent bonds. We'll talk about the scenario where we just have one covalent bond first, and then we can move on. So covalent bond, compounds that are formed by covalent bonds, like I said, are called molecular compounds. The reason that we call them molecular compounds is whereas in ionic compounds we were forming ions, in molecular compounds we form molecules. Now the difference between ionic compounds and molecular compounds is that whereas in ionic compounds we have that transfer of electrons, in molecular compounds we have a sharing of electrons, and the only elements that can share electrons but still achieve that full outer shell are nonmetals. So whereas in the last lesson we talked about how we have a metal transferring an electron to a nonmetal, now we have two nonmetals that are sharing electrons. So a nonmetal sharing electrons with another nonmetal. We'll finish that slide. So here are some examples of some very well-known molecular compounds. So we have water. Water is H2O. It's 2 parts hydrogen, 1 part oxygen. Hydrogen, although it is found on the left-hand side of the periodic table, it's kind of a weird element for that reason. It is a nonmetal. It's a liquid, and it is it's a liquid when it's combined with oxygen. It's a gas on its own. So 2 parts hydrogen, 1 part oxygen. Then you've got sugar in the middle here. Sugar is C6H12O6. Also, all of those, the 6 carbons, the 12 hydrogens, and the 6 oxygens are all sharing electrons in a formation that produces sugar. And then the last one here is CO2, carbon dioxide. Carbon dioxide, very abundant gas, 2 parts oxygen, 1 part carbon, also both nonmetals, so a molecular compound. So a molecule is the smallest independent unit of a molecular compound, and it consists of the atoms of different elements bonded together. Way back at the start of the class, in the start of the semester, I talked about how an atom is the smallest independent unit of an element, while a molecule is the smallest independent unit of a molecular compound. That makes up things. So if we have a whole bunch of water, it'll be made up of a whole bunch of water molecules. So that's my example here below. Water. H2O is made up of 2 hydrogen atoms and 1 oxygen atom, and they're bonded together. They're sharing their electrons, and they form a water molecule. And then you go swimming in a pool, or you go swimming in a lake or the ocean, and there's just tons and tons and tons and tons of water molecules making that water that you're swimming in, or that maybe you're drinking, right? If you had it in a glass. The pair of electrons involved in a covalent bond, remember that's the bond that is the sharing of the electrons that makes the molecule or the molecular compound. The pair of them is sometimes called the bonding pair. So a pair of electrons in the valence shell that is not involved in bonding, so we can have some that are involved and some that are not. The ones that are not involved are called lone pairs. We'll do some drawing, we'll draw some of these, and when we do, you'll see how we have bonding pairs and lone pairs. So right now, we only know how to use Bohr diagrams. Like I've said, we are going to learn how to do Lewis dot diagrams. For the time being, we can use Bohr diagrams to represent molecular compounds. We'll just follow these guidelines to draw the Bohr diagram for the following molecular compounds. So we're going to draw one for HF, hydrogen fluoride. So what I want you to do right now is pause the video and try to draw the Bohr diagram for hydrogen and the Bohr diagram for fluorine on your own. And then when you come back, I'll tell you the next step. So the next step is to look for a possible shared pair. So circle the shared pair if it helps you. And then once you've circled that shared pair, then you can redraw the new molecular compound with the atoms overlapping where the shared pair exists. So I am just going to show you on my document camera how you can do that so you can make sure that you're doing that properly. Okay, so what we are going to do is if you were able to draw them properly, your hydrogen atom, you should draw out your nucleus, and then you should draw out your electron shells for hydrogen and then for fluorine. So there we go. If you drew that one properly, it should look like this. And then go ahead and try to draw fluorine. Remember to find your number of protons and number of neutrons. You take the atomic mass, that's your number of protons. So for fluorine, it is 9. And then for the atomic mass minus the atomic number will give you the number of neutrons. So we go 18.998 for fluorine, which will round up to 19. So 19 minus 9 will give us 10 protons. And just take a peek here. Hydrogen, generally, we've got an atomic mass of 1 and an atomic number of 1. So we subtract those, we get 0 neutrons. Generally, hydrogen atoms don't have neutrons, don't have any neutrons. Sometimes they do. So then draw your electron shells, and I will fast forward here. And there we go. There you have it. So there's our two Bohr models. Now, the question said to, just as a hint, it said to look for a possible shared pair and circle that pair if it helps you. What you'll notice is that all of these other pairs of electrons or all of these other electrons exist in pairs, right? So we want this to be a pair right here. So obviously we want this to share and create a pair with that one. So that's what you could do to help you out. And then your last step would be to redraw the new molecule, molecular compound or molecule with the atoms overlapping where the shared pairs exist. So this part, even myself, I'm not amazing at always knowing exactly how far away to put these. But if I have my hydrogen atom here, I'm actually going to put my electron over on the side because I know where that share is going to happen. And then I've got fluorine, 9 protons, 10 neutrons. Oh, oops, if you were paying close attention, you would have noticed that I accidentally put a P here. This was supposed to be an N for neutrons. And then that's our nucleus. We'll have our first shell. Oh, see, look, I put them a little bit too far apart, but that's okay. Our first shell there, and then our second shell here is going to be kind of big and not very good looking, but that's okay because it gets the job done. And what we see here now is by putting that one there, I now have a happy hydrogen atom and a happy fluorine atom. Fluorine is happy because it wants to have a full outer shell. So 1, 2 on the middle, it's fine. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And then hydrogen wants to have 2 on its outer shell, right? Because it is in the first row. So the first row, if it's full, has 2 electrons on the outer shell. And it does. So there we go. That is the other way in which we can have atoms bond together by sharing them rather than transferring them. So now that you've tried that, now that you've done that and followed along, give these last three a shot on your own. H2O, NH3, and CH4. Pause the video, try them on your own, and then when you replay, I will have an answer key ready for you to compare your answers to. So, if you completed the three examples successfully, you should look like you got something like this, where you have 2 parts hydrogen, 1 part oxygen for H2O, 3 parts hydrogen, 1 part nitrogen for NH3, and then 4 parts hydrogen and 1 part carbon for CH4. And just keep in mind that these right here, these little pairs that are being shared, okay, those are called bonding pairs, and then the ones that are not being shared right here, those are called lone pairs. All right, we'll see you in the next lesson.